Hello guys, welcome back to this channel. On today's video I'll show you step by step how to plot shear force and bending moment diagram easily for this particular problem. So stay tuned. So I have this simply supported beam subjected to a uniformly distributed load of 800 Newton per meter and a concentrated load of 1500 Newton. So the question asks us to draw the shear force and bending moment diagram, determine the maximum bending moment, and finally estimate the moment when at a location when x is equal to 6 meters from the left support of the beam. Before constructing shear force and bending moment diagram, we have to know these important points. Always shear force and bending moment diagram starts from neutral axis and end in neutral axis. So always their value starts from 0 and ends in 0. And this shear force and bending moment diagram represents the distribution of shear force and bending moment across any section of the beam, and maximum moment will be obtained when shear force is 0. So what are the necessary steps to construct shear force and bending moment diagram? So first we have to calculate the support reactions using equilibrium equations. Then we will use the support reactions to draw shear force diagram. Finally, we will plot bending moment diagram by using area method. So area of shear force diagram will give us bending moment diagram. Before analyzing this beam, we have to assign sign conventions, and we have to use this sign convention consistently throughout the problem. So we assume all the forces acting to the right of the beam are assumed to be positive. So summation of all forces acting on the positive x direction to be 0. We assume all the forces acting vertically upward in the y direction to be 0, and summation of all counterclockwise moments to be positive is equals to 0. So we'll use these conventions consistently. So for this beam we have pin support and a roller support. Pin support prevents vertical motion and horizontal motion. So we have reactions in the vertical direction and reactions in the horizontal direction. So we have RAX in the x direction and RAY in the y direction. In case of roller only prevents motion in the vertical direction. So we have RBY. So using the first equilibrium equation, summation of force in the x is equal to 0. The only reaction is RAX. We do not have any horizontal force, so RAX will be 0. Using second equations, summation of force in the y is equal to 0. RAY, which is vertical upward motions, vertical reactions, plus RBY minus 1500 Newton minus a concentrated. We will transform this uniformly distributed load into a concentrated load by multiplying 800 Newton per meter by its corresponding length 3 meters. So RAY plus RBY will be 3900 Newton. Finally, using moment equations, we will solve for either RAY or RBY. Since we have one equations and two unknowns, we'll use this moment equation to solve for either one of them. So let's take summation of moment at point A. So RBY multiplied by its moment arm 9 meters minus 1500 Newton multiplied by its moment arm 7 meters minus 800 Newton per meter, which is a clockwise moment, times 3 meter to obtain a reaction multiplied by its moment term 2 plus 3 over 2 meter. So RBY will be 2100 Newton. Before proceeding on to plotting shear force diagram, we have to balance the upward and downward force and check it. So check upward forces is equals to downward force, and upward forces are 1800 Newton plus 2100 Newton, which is equals to downward force 800 Newton per meter times 3 meter plus 1500 Newton. So upward forces are balanced by downward forces. We have obtained RAY by substituting RBY onto the previous equations, and RAY is 1800 Newton. So let's plot shear force and bending moment diagram. So always shear force and bending moment diagram starts from neutral axis with values 0. So what we'll do is we'll assign these reactions. So at x is equals to 0, we have a reaction RAY, which is 1800 Newton acting vertically upward. So 0 plus 1800 Newton will obtain 1800 Newton. Next, since we do not have any load within this interval between 0 and 2 meter, shear force diagram will be consistent. So 1800 Newton plus 0 load, it will also give us 1800 Newton. But due to this presence of a downward uniformly distributed load, the shear force diagram will not be constant in this region. Hence, it will be 1800 minus 800 times 3. 800 times 3, it will give us minus 600 Newton at x is equals to 5 meter. We do not have any load on this span, so it will be constant. Minus 600 plus 0, it will be minus 600. At x is equals to 7 meter, we'll have a downward force of 1500 Newton. So it will be minus 600 minus 1500. It will give us minus 2100 Newton. On the final span, at x is equals to, at x greater than 7 meter, we will have a constant shear force diagram. So it will be minus 2100 plus 0, we'll have minus 2100. Finally, at x is equals to 9 meter, we'll have a reaction RBY of 2100 Newton. So minus 2100 plus positive 2100 will give us 0 value. So the shear force diagram starts from 0 and ends in 0. So the next step is to locate points of 0 shear. So the point of 0 shear is at this point. So we will use similarity of a triangle to determine this y value. So using rise over run, the rise is 1800 plus 600, it will give us 2400 divided by the run is 3 meter, which is equals to 1800 divided by y. So y will be 2.25. So 3 minus 2.25, it will give us 0.75 meter. Next, we will calculate bending moment diagram. Remember that bending moment can be obtained by calculating area of shear force diagram. So the area of shear force diagram is equals to bending moment diagram. So at x is equals to 0, we have only a line. So area of a line is also 0. So 1800 times 0 will give us 0. At x is equals to 2, we will have area of region A. area of region A is area of a rectangle, so 1800 times 2 meter, it will give us 3600. Proceeding, at x is equals to 4.25 meter, we'll have area of region A plus area of region B. So area of region B is area of a triangle, so area of region A is 3600 plus half, the base is 2.25, the height is 1800. It will give us 5625 Newton meter. At x is equals to 5 meter, we'll have area of region A plus area of region B minus area of region C, since region C is located below 0. So it will be area of region A 3600 plus 5625 minus half, the base is 0.75, the height is 600. So we'll have 5400 Newton meter. So this will be the bending moment diagram up to x is equals to 5 meter. Then at x is equals to 7 meter, we have to calculate area of region A plus area of region B minus area of region C minus area of region D, and it will give us 4200. At x is equals to 9 meter, it will be area of region A plus area of region B minus area of region C minus area of region D minus area of region A, and it will return, the bending moment diagram will return to 0 value. So to summarize, at x is equals to 0, we'll have 1800 times 0, it will give us 0 value. At x is equals to 2, it will be area of region A. Area of this rectangular region will be 1800 times 2, it will be 3600. At x is equals to 4.25 meter, we'll have area of region A plus area of region B. At x is equals to 5 meter, we'll have area of region A plus area of region B minus area of region C. At x is equals to 7 meter, we have area of region A plus B minus area of region C plus D. And at x is equals to 9 meter, we have area of region A plus B minus area of region C, D and E. Maximum moment can be obtained when shear force is equals to 0. So the value will be 5625, and its location is at x is equals to 4.25 meter from the left support. So to determine the moment at x is equals to 6 meter, so x is equals to 6 meter is located at this point with broken red line. So if we calculate the area from this point up to this point, we can obtain the bending moment value. So it will be area of region A plus B minus C and parts of region D. So its value will be at x is equals to 6 meter, 1800 times 2 to represent region A, half 2.25 times 1800 Newton to represent region B, minus 1/2 times 0.75 times 600 to represent region C, and to represent parts of region D, we will take minus 600 times 1, minus 600 times 1 meter. So it will give us 4800 Newton. So thus, if you find this video helpful, don't forget to subscribe.